Hi guys, today I'm going to teach you how to calculate the volume of a sphere using calculus. Okay, so let's get down to it. My plan of attack here is going to be, we're going to calculate the volume of half the sphere, okay? And then we're going to multiply to the bottom half, multiply by 2 to account for the bottom half. Why do we do this in calculus? You just, when you want to integrate this stuff, you just want to integrate what really matters. If it's symmetrical, you just take care of the unit part, the atomic part that you can't get rid of. In case of a sphere, it's just going to be the top half, and you just multiply the bottom half, which is symmetric to the top half, later. Why? Because if you're integrating and you run into an even function, the bottom half is going to cancel out the top half, and you're going to end up with a volume of 0, which is not what you want. So you just care about the top half. Okay. So what we're going to do is add all these disks in here. Okay, we're going to add the first disk and the second and the third and blah 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 from bottom to top. It's not going to be from top to bottom. It'll be from bottom to top. And we're just going to get the volume of the sphere this way. You got to consider that there's an infinite number of disks in here, and they're infinitely close to each other with an infinitely small thickness. Okay, so much that you just consider the area, you don't consider the height of each one of the disks. So let's get down to it. I'm just gonna do this. Add this one, plus this one, plus this one, plus this one, you're gonna end up with the volume of the sphere. There's something else that I wanna show you guys too. Okay, I'm gonna make this disappear in here. Now, you see this? This circle right here, we're talking about the x and y axes. Okay, so think about this circle right here. This circle is this one here. Okay, it's not this circle. It's this circle here. Going this way, that's this circle here. So this is going to be, well, in the case there, this is going to be x, up out of the floor is going to be y, and the depth in here is just going to be z. Okay, but you don't have to worry about z. You just worry about x. Okay. So let's do it. You have a disk in here, okay, with this radius. And what's going to be the radius in here? Because you have to add these disks. So you know that's going to be the integral, okay? Since you're going in the y direction, it's going to be from 0 to r, because that's the value of y in here. It's going to be r. And then it's going to be what? Pi r squared. But what is r squared for each one of the, what's the radius squared for each one of the disks? It's going to be the value of x. See, this is r, and this is r, and this is r, and this is r. As x becomes smaller and smaller and smaller, and it gets all the way down to 0, that's what you care about, the value of x. Now, how do you calculate the value of this x in here with respect to this y? Okay, you gotta remember that this is the whole thing represents a sphere in orthographic camera, but this drawing here is just a circle. So what is the equation of the circle at the center? Okay, with the center at the origin. The equation of a circle whose center is at the origin is x squared plus y squared equals r squared. So x squared is just going to be r squared minus y squared. That's what we're going to plug in here, because you see the radius is going to be x. So you got to do pi x squared dy. But you can't just leave this x squared in here. You got to relate the x squared to y somehow. So I'm going to get the pi that's multiplying everything out of the integral, because it's a constant. Okay. And now we do x squared dy. What's x squared? It's r squared minus y squared. So r squared minus y squared dy. And now I'm going to erase this thing that I did here. Okay, so let's integrate this. It's going to be pi times r cubed, actually we're integrating with respect to y, so it's going to be r squared y minus y cubed divided by 3, okay, from 0 to r. Now, somebody may ask, okay, we got the pi, which is a constant out of the integral. How come we can get the r, which is also a constant, the radius of the sphere? It's not going to change. It doesn't depend on y. So why don't we get it out of the equation too? Well, it's because pi is multiplying everything. So if it's multiplying everything, you can get it out of the equation. Now this r is not multiplying the y, okay? It's just the r is just one of the terms in the addition, in the sum, so you can't get it out by itself. You have to make it part of the integral too. So this is going to be pi, okay, from here all the way to here, it's going to be pi times r squared, and you're going to plug this r in here. It's just going to be r cubed minus, you got a y, you plug the r in here, so it's going to be r cubed divided by 3, okay? Now, you have to plug in the 0 too, you have to go minus, but plugging in 0 here is just going to get a 0, and plugging in 0 here is just going to get a 0, so don't worry about it. So what do we have here? We have pi. You have r cubed minus r cubed divided by 3, so it's 1 minus 1/3, which is 2/3, okay? So it's 2r cubed divided by 3. But this is just half of the sphere, okay? You also have to multiply by these discs in here, by the addition of these discs. So you have to multiply the whole thing by 2. Multiplying it by 2, you get 4 pi r cubed divided by 3. And that's the volume of the sphere. Okay? That's it.